This lesson will cover graphing quadratic functions in vertex form. Before we graph any type of function, it's always nice to know what type of shape we expect when we graph it. In the case of a quadratic, we expect to get what is called a parabola. Now there's some defining features of a parabola that we need to understand. Right here is an example of a parabola. Four of the pieces that of information that we need to talk about in regards to a parabola is number one, x-intercepts. X-intercepts are the locations at which your graph intercepts the x-axis. In our case, we have 1, 2 x-intercepts. Now, we could also have a case in which maybe our parabola comes down, barely touches the x-axis, and then goes back up. In that case, we would say we only have one x-intercept. It would be that bottom turnaround point touching the x-axis. And we could think of yet another example where the turnaround happens before we even reach the x-axis. So going back up to the statement here, this is why we say there are 1, 2, or 3 or 0, 1, or 2 x-intercepts. The next thing we need to talk about is the y-intercept, also known as the initial value. The y-intercept is the location at which our graph crosses the y-axis. For us, that's down at -3. Now, because the domain of a quadratic is all real numbers, meaning it travels forever in the positive x direction and forever in the negative x direction, we know that at some point our graph will always cross the y-intercept, but only once. So there is always one y-intercept. The next thing that we need to talk about, which is in many cases one of the most important pieces of a quadratic, is what's called the vertex. Now the vertex is either the maximum or minimum point on our graph. Otherwise, it can be viewed as the turnaround point. For instance, looking from left to right, our graph is decreasing, decreasing, decreasing until we get to this turnaround point, which we call our vertex, at which time it starts increasing. So it turns around from decreasing to increasing. That point is called the vertex. The last and fourth piece that we need to talk about is the axis of symmetry. The axis of symmetry is the vertical line that intersects the vertex and splits the graph into two halves that mirror each other. Parabolas are symmetric. The line of symmetry is that line that goes through our vertex, and as you can see, splits our parabola in half perfectly, each side a mirror image of the other. We would say that our parabola has symmetry about our line of symmetry. The equation of the line of symmetry, being a vertical line, we know it's x equals whatever location our axis of symmetry is going through the x-axis, in this case 1. So we could say that our axis of symmetry is the equation x equals 1. Now the example that we've been looking at, the parabola opens up, when in fact parabolas could open up or down. So this figure over here illustrates the two different scenarios of the parabola opening up in this case and the parabola opening down in this case. Now we're working with the vertex form of a quadratic function, not standard form. So vertex form here is y equals a times x minus h squared plus k. So we're going to be looking at quadratics that are in that form, where x and y are the variables, a, h, and k are constants specific to whatever quadratic function we're working with. Now this value of a is the value that tells us whether we open up or down. If the value of a right here is positive, meaning a is greater than 0, our parabola opens up. What does that mean about our vertex? It means that our vertex is the minimum value on our graph. Conversely, this value of a, if it is less than 0, in other words negative, our parabola opens down. What does that say about our vertex? It says that our vertex is the maximum point. In both cases, a being greater than or less than 0, the vertex is the turnaround point. But in the case of a being greater than 0, our vertex is a minimum. In the case of a being less than 0, our vertex is a maximum. So we have an idea now of what our graph of a quadratic, what the graph of a quadratic function should look like. Should look like a parabola, exhibits symmetry. It should open up or down. It either has 0, 1, or 2 x-intercepts, and the vertex is our turnaround point. So let's go ahead and start talking a little bit more about the logistics of how we graph a quadratic function. Graphing a quadratic function starts with the vertex. When in vertex form, which we have seen as y equals a times x minus h squared plus k, the vertex of a quadratic function is the point hk. So the values of h and k give us the x and y coordinates of our vertex. So simply by inspection, we can look at a quadratic function in vertex form, and the two numbers in those locations serve as our x and y coordinate of our vertex. Now the one piece to be careful with is this value of h right here, because you'll notice that in here it's x minus h, yet in our vertex formula it says h. So for instance, if it said x minus 4, the number we would pull out would not be negative 4, it would just be positive 4, because we're ignoring the negative when we bring it out. Now the steps to graphing a quadratic function are the same whether you're in standard or vertex form. We're going to start by, number 1, calculating the coordinates of the vertex. In this case, it's just hk, and then plotting the coordinates on plotting this point on the coordinate plane. Next, we're going to construct a t-table around the vertex and evaluate each x value selected in your t-table. These two are best described through some examples, which we'll get to. Number 4, we're going to plot those coordinates calculated in our t-table on the coordinate plane. Once we do that, we have several points, so step number 5, we know that we can now connect the points on the coordinate plane in the shape of a parabola. Lastly is just making sure we communicate information appropriately. Number 6 says we need to label the vertex and 2 additional points. And number 7, we need to draw and label the axis of symmetry. This just allows the viewer of your work to have a little more information and detail about the important pieces of your parabola.